So good morning to all of you. So in today's class, we're going to discuss about state chart diagram. Now, state chart diagram is a diagram that tries to define the behavior of a single object or a set of objects that are related by collaboration. It is a diagram that is capable of representing all possible states that the object may attain during its lifetime as a consequence of internal or external event, right? So it is a diagram that is capable of capturing all possible states that an object may attain during its lifetime because of internal or external event. Now states of the objects are being defined by the values of the state variables that are called as attributes. So each of the object each and every object has a set of attributes that defines the state of the object. So a particular set of values to the attributes of an object defines the state of the object, right? Okay, so a chart diagram is a diagram that tries to model the lifetime of a given object or the entire life of a given object. Now state chart diagram has the following components. So it has states, it has messages, right? Now state can be initial state, or it can be final state, or it can be intermediate state. Now initial state is a state where the object is actually created. You do not have any state before this. Okay, so it is called as a pseudo state because at this point in time object is just created, but the attributes are not initialized with any value, and it is represented with the help of a filled circle. So initial state has four characteristics. It is the point in time when the object is created. You do not have any state before this. It is represented with the help of filled circle. It is represented with the help of filled circle, and it's called as a pseudo state because the objects are not initialized with any value. Final state. This is the state beyond which we do not have any state. This is the point in time when the object is actually destroyed. Okay, the object is actually destroyed, and at this point, this is also a pseudo state because at this point in time, since the object is destroyed, so we do not have any values for the attributes of the object, and it's represented with the help of a bullseye. So these are the four important characteristics of important initial state and final state. Again, I'll repeat it. Initial state is a pseudo state that before which there exists no states. It is represented with the help of a filled circle. It is called a pseudo state because the objects are not initialized. Okay, it is the point in time when the object is created. So final state, there is no state beyond this. This is also pseudo state. This is the point in time when the object is actually destroyed, and it's represented with the help of a bullseye. Now in between intermediate initial state and final state, we have the intermediate states. So intermediate states may be a simple state or may be composite state. That means it may be a simple state or a state that is composed of multiple states. Then we have events. So events are action that leads to state transition. So for an example, if I add value 1 to variable x, so if x is 1, so 1 plus 1 would be 2. So the state transition of x would take place from 1 to 2. So that is the way how the events are represented. So if with the events, what we have is we have associated guarding conditions, right? Again, we have actions and we have event syntax. Now, as we talked about, state can be simple state or a complex state. So a complex state has a set of activities, it has a set of entry criteria and set of exit criteria. So now let us move on to state. Definition of state. So state is a current condition of the object reflected by the values of the attributes belonging to that particular object. So state is the current condition of the object reflected by the values of the attributes belonging to a particular object. Now initial state and final state. So we have already discussed. Initial state is a state where the object is created. You do not have state before this. It's called as a pseudo state because at this point in time the attributes of the objects are not initialized, and it's represented with the help of a filled circle. Now, and we have final state. A final state. So this is a state beyond which we do not have any state. So this is the point in the time when the object is actually destroyed. So this is also a pseudo state, and it's represented with the help of a bullseye. And we have events. So events can be either receipt of signal, or it can be either invocation. So event is occurrence of stimulus that causes state transition or that triggers state transition. Now event action. So the response to an event has to explain how the change to the attributes of the objects are brought about. That is called as event action. Now, so you can go through the event syntax, and let us discuss an example of state diagram. So here I have a very simple example of state diagram where we are trying to represent the various states that an ATM machine may be. So here what we have is we have off state, we have self-test state, we have idle state, we have maintenance state, we have out of service state, and we have the serving state, right? Again, so now serving state is a composite state. Now just see here. So initially the ATM machine is in off state. Now once we turn on the ATM machine, the ATM machine will go into self-test state, right? Again, and once the self-test is done, it will go into an idle state, right? It will anticipate for the card to be entered, right? So if the card is falsely entered, so it will send up a cancellation message, right? And at point in time when in idle state, if the ATM machine is to be serviced, so here for performing service, it will go into maintenance state. Again, once it is maintained, it will go to self-test state, right? Again, and the process repeats. So it may so happen that after self test, the system is in idle state and the card is inserted. So once the card is inserted, the card is read, right? Again, and customer authentication is done, transaction is selected, transaction is performed, and this particular complex state terminates, right? So here, based on a valid transaction that the customer performs, first authentication is done, transaction selection is done, transaction execution is done, and that this particular complex state gets over. Again, the system moves back to idle state. So that also may happen. So one situation may be, one instance maybe, so an example, system is off, it is turned on, it will go, a self test is done, it will go into idle state, card is inserted wrongly, it will send up a cancellation message, again move back to idle state. Or system is turned on, it will go into self-test state, so the system will go into idle state, right? A card is inserted, entry criteria is satisfied, custom authentication is done, selection of transaction is done, transaction is executed, again it goes back to the idle state. Now during idle state, it may so happen that the ATM may require certain amount of servicing, so it will go to some maintenance state. So from the maintenance state, if the maintenance is successful, it will go to self-test state again. Again the process repeats. Okay. Now, it just so happen during maintenance there might be fault or problem that may be encountered, because of which the ATM machine may not work. So in case of failure, the ATM machine will go into out of service state. If it is serviced, it will go into maintenance, again self-test state, and the process repeats. Now if the machine is turned on, if it goes into self-test state but it does not work, there is a failure, so it will straight away go to out of service state, right? So if from out of service state, if the system cannot be maintained, then what will happen is we have to turn off the system and wait for the maintenance work, or wait for the maintenance engineers to come, right? Okay. Now that is the way how the interpretation of this particular diagram is done. So now during the servicing state also, what may happen is that if there is a link failure, then the system may exhibit failure, so it may go into out of service state, right? Again, which may call for maintenance, right? So again maintenance is done, so again self test is done, again this particular process repeats. So just see, this is what happens to an ATM machine. So here what we are trying to represent is we are trying to represent various states and the state transitions. So we have the ATM machine off state, self-test state, idle state, maintenance state, out of service state, and the serving state. Right. So this is a very simple state diagram that tries to represent the transition of state of an ATM machine between various states, right? Okay, we have also represented simple state as well as complex state. So in today's class, what we have learned about is we have learned about what is a state diagram, right, or a state chart diagram. We have learned about the attributes of the state chart diagram, right. We have learned about the components of the state chart diagram. We have learned about what are the different types of states that may be there. We have learned about initial state, final state, and intermediate states. We have learned about the way how the state transition takes place. We have learned about what causes the state transition. We have learned about the properties of the events, right? We have learned about complex state. Then we try to define a state, and we try to understand what is the initial state. We have what is the final state. So we try to associate Characteristics with the initial state and the final state. We've learned that initial state is represented with the help of field circle. There is no state before this, right? This is the point in time when the object is created. So this is a pseudo state because the objects are not initialized. Final state is a point in time when the object is destroyed. It's represented with the help of a bullseye. So there is no state beyond this. Okay, so this is also a pseudo state, right? Now then we had talked about intermediate state. So we talked about we can have a simple state as or a complex state as an intermediate state. Then we talked about events. So we talked about what may be the types of events that may be there. It may be received a signal or it may be invocation call. So event is the occurrence of a stimulus that can trigger state transition. So we learned about event action, right? Then we learned about event syntax, and then we tried to understand state diagram with the help of a state chart diagram for an ATM machine, where we try to reflect various states of an ATM machine. We've seen how to represent the complex state, and we've seen how to represent the simple state, and we've seen how to represent the state transition. Okay, so thank you very much. We'll continue in the next class.